Definite integration is where we integrate between two limits, giving us an area between the curve and the x-axis. So if we look at the equation x squared plus 2, we can integrate between any value we want. So we can integrate, for instance, between 1 and 2. It's the area shaded green that we're going to calculate. This is how we write the integration. It's the integral of x squared plus 2 from the lower limit, which is 1, to the upper limit, that's 2. So integrate x squared plus 2, and that's exactly the same as usual, which is x cubed over 3 plus 2x. But instead of a constant of integration, we draw a line at the end, and we have the lower limit and the upper limit. Notice there's no constant of integration. That's because we have limits of x equals 1 and x equals 2, and that removes any uncertainty. So now what we're going to do is evaluate the integral with x equal to 2, and then we subtract from that the value of the integral with x equal to 1. So with x equal to 2, we get 2 cubed over 3 plus 2 times 2, and then we subtract from that 1 cubed over 3 plus 2 times 1. We now calculate the value to get 13 over 3. So the shaded area in figure 19.1 is equal to 13 over 3. This area here is equal to 13 over 3. Now we'll do an example. What's the integral of cosine theta from 0 to pi over 2? So I is equal to the integral between 0 and pi over 2 of cosine theta. Integral of cosine is sine, and those are the limits, 0 to pi over 2. The sine of pi over 2 is equal to 1. The sine of 0 is equal to 0, so 1 minus 0 gives us 1. What would have happened if we had been integrating from pi over 4 to 3 pi over 4? Let's look at figure 19.2, pi over 4 to 3 pi over 4. If we put those values into the integral, we get 0.7071 minus 0.7071, and so our answer becomes 0. So what that says is that the area here is 0, which is clearly not right. So what do we do? What we have to do in cases like this is to notice that this line is symmetrical about pi over 2. So what we can do is integrate from pi over 4 to pi over 2 and then double the area. An alternative method is to integrate from pi over 4 to pi over 2 and then separately integrate from pi over 2 to 3 pi over 4 and then add the two bits together. We'll do the first one here. So what we're going to do is integrate from pi over 4 to pi over 2. That's going to give us 1 minus 0.7071. Subtract those and we get 0.29, and then we want 2 times that, which will give us 0.59. So this area is actually equal to 0.59. You should now be in a position to do questions 15 to 18 in the chapter on integration in the textbook.